Welcome to the VB Toolbox. In this tutorial I will be teaching you how to parameterize your Microsoft SQL queries from your VB.NET application. Parameterized queries are a good first line of defense against SQL injection attacks against your database by malicious users of your application. In this tutorial I will be using the same database that I've been using in all my database tutorials. It's just a very basic forum structure application database. I'm going to be focusing on this members table again, using the source code from my last tutorial, which was showing you how to create a login screen for your SQL Server. So I'm going to go ahead and open up that project. If you don't have that project, you might want to review the last tutorial, creating a login screen for your SQL application. Otherwise, I will probably be posting a link to the project source in the About section of this video. So as a brief reintroduction to the SQL login demonstration that we had done before, we'd created this app that accepted a username and password, and if that password was checked successfully against the database and the username, it would bring up the user's profile in this informational box down below. So if I bring my database back up here, I can look and select a user from here. I have 10 users. Using Ambrosia 21. I love code, and then I select logon, and Ambrosia 21 was successfully checked against the database, and it returned that user's profile. So beyond that, what we had created was a SQL control class that holds all of our SQL instructions, our query instructions, and a connection test. And there's my connection string up there showing how I connect to my database. And finally, in Form 1, we have our login button and our profile information box down here. So we had created a function to check whether the user is authenticated, and what you can see here is, we're building this query, and we try to keep our applications as dynamic as possible, but the more dynamic they are, generally the more vulnerable they are to SQL injection attacks. And what a SQL injection attack is, essentially, is when a malicious user modifies your query string at runtime. Okay, so as you can see, this query string is built from our username text box and the password text box. And what they'll generally do is modify this filtering scheme and make it so, regardless of whether or not they get the username successfully, whether they choose an existing username or password, they will make this return a true value. Since this value needs to evaluate or return a true value, essentially saying username equals the username in the text box. Okay, if that username is found, this returns a true. So what they do is they force a true value by modifying the query string at runtime. I'll try to actually do a demonstration here. If I take my username here and enter X, okay, and then I force the current string here to terminate by inserting a single quote, what you can see here is that the username return is going to be X, and it's going to terminate prematurely. So this single quote's left hanging at the end, and what I can do is implement an OR here, and then add any value that I could force to be true. So for example, I could open another string here, insert x, and say x equals x. And what I do is I avoid putting on the final single quote, because this one will then terminate my string. So what I've done is I've said where the username equals x, which we know is false because there's probably no username x in the database, or x equals x, and x of course is going to equal x, and so it's going to return true for the username regardless of whether an actual username was found in the database. So you can see how that could be very dangerous, because then the malicious user could return all user data for all users in the database, okay, and possibly get access to information like the password field and stuff like that that they shouldn't have access to for all the other users. That's just one example of many types of SQL injection attacks. You know, there is the popular one where they terminate the string and the query prematurely by entering a semicolon and then fire another command at the database, like drop table members, and then throw in a comment. 2 dashes makes a SQL comment, so anything coming after that point would just be canceled out, and then this would be executed against the database. Now ATONET, the ATONET connector kind of protects against that just a tiny bit by differentiating between the SQL data reader and the execute non-query. I don't have the execute non-query in this example here, but if we took the SQL command and ran execute non-query, you know, then that could fire a drop command or any other table updates, deletes, inserts, and things like that. Now they can't modify that at runtime, but if you had a dynamic query setup, kind of like we have a dynamic query setup here that will accept any query string, if that query string's been modified by the user, then it will be passed and executed against the database. Even if it is just a read query, they could still get access to maybe admin account information and things like that that would give them higher privileges in your database. So things to keep in mind, and I will show you an example of this as we go. So we'll go over to the is authenticated area here, and this is where we're going to add a couple of message boxes to kind of give an example of what I'm talking about here. I'm going to fire a SQL injection attack against my little database here for you. So the first thing we want to do to see what our query string looks like when we run it, I'm going to add a message box, and I'm just going to copy this entire query string over to that message box, so it will display it to us at runtime. Okay. And the way that I'm handling my logins is, you know, not the same as what everybody does. Everybody usually has a little bit different login scheme. What I did is I just selected a count of usernames that were found in the table. But even this is still vulnerable against the injection, because this part here can be modified by the user and executed. But down here, I'm going to test SQL injection. If I was actually returning the username and, you know, the password instead of just returning a count of all usernames found, then you know, the end user would actually see that username and password returned, or they would at least have access to that, and depending upon how your system is coded or what you're actually trying to do. Login screens are not the only vulnerable part of a SQL application. Naturally, you usually have all sorts of components in your application. You know, you could be entering employee names or part numbers or anything. Anywhere you've got a query string that you're dynamically updating from your text boxes and accepting user input, you know, there's a potential risk there. So down here, what I will do is I will say message box, and I'm going to take my SQL. SQL is my reference to my SQL control class that we created in the previous tutorial. And I will access from there the data set, so SQL DS, and that is our data set that we create here and fill when we run the query. Okay. So that runs the query against the database. The database returns the records that it discovers and loads them into this data set, and then we have access to the data in there. I'm going to grab table 0. There's usually one table return, and for the rows, I'm just going to grab row 0, because in my query I'm only returning one value here. And the item that I want to return is user count. That's the name of the field that I'm returning. I named it user count here, which is a count of all users found that match txt user.txt. And I'll close that message box. So let's go ahead and run this and see what happens. I want to see what my query string looks like when I use Ambrosia21. I love code. And if you recall from the first tutorial, this collate section tells my password, you know, to check it in a case-sensitive manner. So if I enter I love code in all lowercase, it's not going to match her password. So it is case sensitive, and that's what does that. So I'm going to go ahead and log in here. Sorry about the slowness of my database on my dinosaur computer. Give it a moment here to connect. Alright, so it's firing this message box up here and revealing our query string. So as you can see, it's a, you know, nicely formed common query string, and we hit OK. It tells us that one user was found, and that's exactly what should happen. You shouldn't have the same username more than once in your database. And then it successfully returns. If I run Ambrosia22, tries to find username Ambrosia22, shouldn't be able to find it because it doesn't exist, and returns 0 users. Okay, and tells me that invalid user credentials were entered right here. So what if I fire a SQL injection attack at the database and effectively modify my query string? So I'm a malicious user here. I know that the username is looking for a string here, so I'm going to prematurely terminate that string, throw in an OR, so either one has to be true. We know that this will be false. The malicious user knows that that's going to be false, so all we have to do is force it to find a true value. So we throw in a string x, say x equals x. Well, of course x equals x. Now I'm not going to throw on the ending quote here because that's going to be captured right here. This still exists in the query string, so it's just going to inject this and then take off from there. Now, what I'm going to have to do here to successfully do this, because if this is false but this is true, you know, the first one is captured successfully, but the password is still going to return a false value if I don't know it. So what I'm going to do is copy this same string down to my password box and inject it in there. Okay, and I'm going to hit login, and we'll see what our string looks like now. Select count username as user count from members, where username equals X, we know that's false, or X equals X, we know that's true. So password was, or the username was successful. Password, that's a fail. There's no X in the passwords to match, but or X equals X. So we have a true value on the first statement and a true value on the second statement. SQL should think that that is A-OK. So we're going to hit enter or OK, and notice what we're seeing here. All 10 users were returned successfully from this login. Now it's going to go ahead and tell me that the login failed because I had a little catch string down here, or a little if statement to catch. If there's more than one user found with those credentials, then return, or I'm sorry, if exactly one user is returned, then return true. Otherwise it's going to be false. So the fact that I returned 10 users, or more than one, was captured here, so it's just going to skip over the actual true and tell me that it's false. However, in the meantime, the user has already gained, the malicious user has already gained access to all 10 users in the database, as we can see here. So if we were outputting username and password here in our data set, then he could have captured the usernames and passwords for every user in the database. So it goes through, it says invalid credentials because more than one user was returned. So what I'm going to do is show you how to parameterize these queries and prevent that code from being injected into the query string. So let's jump over to our SQL control class. And in here I'm going to create a new kind of query. I'm going to create a parameterized query, but before I do that I need a place to store the parameters. So I'm going to at the top of the class here, I'm going to add a public variable SQL params as a new list of SQL parameter. Okay, and this is coming from our SQL client namespace. So we're going to create a list of parameters, and each time we run the query we'll fill up this list as desired, keeping it kind of dynamic, and then when the query is done we'll flush that list. You know, so future queries can add their own new parameters to it. Keeps it dynamic. Now that we have that, let's go down and create our parameterized query. So we don't want this run query. I'm going to say public sub param query, and I'm going to pass a couple of parameters into this, not related to the query parameters themselves, but we want to pass our actual query string in. So we'll say query as string. And one thing that I added, because you know we're doing a user login form here, we still want to check and make sure that the password is case sensitive. So we're going to make an option for this collation here, and that's going to be optional. So what I'm going to do is say optional collate. Actually, before we do that, we're going to need to enumerate those. So I'm just going to go ahead and close this real quick here. Whoops, I accidentally messed up my class there. Sorry about that. So before we do this, I'm just going to add a public enum down here real quick. Called collation. So I'll say public enum. That just creates a collection here. I'm going to say none and case sensitive. Helps if you spell them right. Alright, now I can use this in my query parameter, so I'll say optional. Well, let's see here. Optional collate as collation. And because we're giving it an optional value here, we have to set a default to fall back to, so I'm just going to say collation none. Okay. So with that, we're ready to begin our query setup, and we're going to use a try catch to capture any failures of our query against the database or connection or anything else like that. So I'm going to do a try, and first thing we need to do is open a connection to the database, so we're going to use our SQL connection up here, SQL Con. Alright, and I like to just terminate that as well so I don't forget in the end. Open it, close it, do stuff in between. Alright, and now we're going to modify our query string if we have selected case-sensitive collation. So, you know, every object we put in there we might not want to collate. So this is just for the password at the end of that. Let's say if collate equals collation case sensitive, then query equals query, and we'll just append that collation value. I'm just going to copy and paste it over there with spaces. Alright. So collate SQL Latin general, and this causes the case sensitivity here. So, but it's only appended at the end, so it's going to be the last field in the list, which in this case is the password field. Okay, let's see. Now we want to generate our SQL commands. So we're going to do SQL CMD as defined up here, and that's going to be a new command equals new SQL command, and we'll be passing the query into that command, and our SQL connection will be used to open the database. So this tells it where to go, and this tells it what to do. And now what we're going to do is loop through this list of parameters. So if there are any parameters in here, we want to add them to our SQL command at this time. So I'm just going to say for each p as SQL parameter in SQL params. So it's going to search through that list, and any parameters that it finds, we're going to add it to our SQL command SQL CMD dot parameters dot add p. Okay, so whatever parameter it finds. And now we have to, for each parameter, we can't just add the name of the parameter, we have to add the value as well. So SQL cmd dot parameters, and I want to get the current one, the current parameter we're looking at, which is p. So p dot parameter name. So we call it by its name from whatever is specified. And then we set the value to be equal to p dot value. So we're essentially copying whatever parameters exist in this parameter list over to our current SQL command. And that's all there is to it. At this point, we are going to fill our data set. So fill data set. And to do that, we use a SQL data adapter and a data set. So I'm going to do SQL data adapter equals a new SQL data adapter, and we're going to run this data adapter on SQL command. So this executes our SQL command at this point. Once the parameters have been added, it gets fired off, and then we create a new data set. So we say SQL ds equals new data set, and then we use the data adapter's fill method to dump all the data that it gets from this command into our data set. So SQL da dot fill, and here we select the data set that we want to fill, SQL ds. Alright, so that concludes the query. Now, at this point, we want to know what our query string looks like, because I want to compare it to what we saw before when we ran the SQL injection. So I'm just going to throw in a little message box for testing, and I want to return the query string. I'm going to drop it down line bbcrlf, and here I want to return the first item that it found from our data set. So I'm going to say SQL ds dot tables 0 index, and rows, also the first row and the first item. Okay. And we can do this okay only success. So that'll indicate that the query was successfully run. And now if we have any errors or exceptions, we want to capture those. So first thing we want to do is, if for some reason this query bombs out, we want to make sure our connection gets closed. If it crashes up here, it's not going to fire our close method here. So what we want to do is say if SQL con.state is open, then SQL con.close, and that just makes sure we close the database, otherwise we won't be able to run more queries to it after it fails. Then we can throw back message box query failed, and we could throw back the error ex.message so the user can tell why it crashed. And again, we might want to see what the query looks like at this point, just in case it does fail. So I'm going to say message box query. So it's going to fire the same query string down here. And finally, we're going to want a way to clean up our parameters when we're done using them, so they don't just kind of stick in the class. So I'm going to create a flush params sub down here. I'm going to say public sub flush params just to dump that list. It's going to be really simple. All we're going to do is reference that list, SQL params dot clear. So anything in there just gets dumped. And then we can come back up to our param query, and after it's all said and done, just run it one way or the other. Alright, so that flushes the parameters. Now we need one more thing. We need to be able to add new parameters to our list. So what I'm going to do is add one more sub here. Public sub add param. Oops. And I'm going to need to specify some of the properties of that parameter. One important one is the name, so we want to give it a name. That'll just be a string value. And the value as an object, because that could be any data type. It's not necessarily just going to be a string. It could be an integer or a Boolean or whatever else you want to pass to your database. So checking data types is another method of data validation that can kind of help you just sort of manage what sort of query data is passed into your query engine. So you can enforce certain data types. You do something like optional data type as DB type, and then give it a default value of something like string to fall back on. And that way you can enforce, so if you're expecting your user to enter a specific value like an integer or something, and they try entering a string that might be a SQL injection, you could fail that back if you wanted. So just more things to keep in mind. There's not just one method of SQL injection. There's a whole bunch of different methods and different database types, but you gotta implement as many layers of security as you can to keep it safe. So let's go ahead and create this parameter. I'm going to just call it new param as a new SQL parameter, and I need to give it a name, so I'm going to say with, and open a curly brace here, and then I can give it some default properties here. The first one is going to be the parameter name, and we're going to get this from name up in our method parameter. And the next one is going to be our value. So I'm going to look for dot value and set that to be equal to whatever is passed through here. And finally, if you wanted to, you could throw in your DB type equals data type. And I think that's all I need. Oops, I don't need that. Okay. So we've added our initial properties to this, and this object will be stored to our params list that we created. So that's what we'll do next. We'll say SQL params dot add our new parameter. So now we can add these at directly from our form over here by referencing our SQL class, our SQL control class. Oh, let me think, is there anything I'm forgetting here? I think we're about ready to test this out, so let's jump back to our form design. We're going to need some way to test this. I'm just going to add a new button to the form over here. And I'm just going to change the text on this to param query. And I'll just use this button to test it. So in our button click event, if you double click on your button, it'll generate this. And now we're ready to try adding some parameters. Well, we know that our username, our user authentication query here has two parameters that we want to pass in, the username and the password. So I'm going to add two new parameters. I'm going to say SQL.addParam, that's the sub that we just created, and I'm going to do one @user, that's the name, and then the value is going to come from txt user.text, so that passes the username. And I'm just going to do a string value, db type string. Remember, that was optional, so you could leave that off if you wanted. SQL.addParam. I'm going to create a second parameter, and this one's going to be for the password. I'm just going to call it @pass. And txtuser.text is going to be where the value is coming from. And again, we're going to do a string db type there. And now we are ready to run our parameterized query. So once we've created our parameters, they get added to the list, and then when we execute the query, it sorts through that list and finds each name and value and creates a new parameter for a SQL command. So we'll say SQL dot param query, and in here I am going to add my query string. So I'm going to say select username from members, where the username equals @user. Okay, and notice how I'm forcing a value through here, and rather than just concatenating on directly from the text field. Okay, and I'll show you how this works here in a moment. And password equals @pass. Okay, and I want to concatenate on, make the password case sensitive. So I want to collate, and so that should be ready to run, assuming I didn't make any huge mistakes here. So this should run through here, and if it's successful, it should fire off this message box, show us the query string, and even if it's not successful, it should fire back the query string and show us where it's broken. So I'm going to go ahead and kick it off here, and I'm just going to enter any value and hit my param query. Take me a moment for it to connect to the database. Alright, so it did not return any values, and it's going to show me my query string. Now, something you'll notice here is that you never actually see the values that I entered, and that's because they're being passed through these parameters. They're like variables for the query, for the SQL query, and the way that that works is rather than executing the entire query string as it stands, the parameters get passed into the SQL engine and processed in the background. Okay, and it knows how to it basically just forces those values as a literal value into the field. So rather than actually incorporating whatever's in that value into the query string like we are before. I hope that makes sense. But it basically it blocks that SQL injection from ever actually becoming part of our query string. So you never actually see it here. Similarly, stored procedures used on your tables also accept parameters, but from the actual database end instead of like this. So you can pass in, and then you just execute the stored procedure with your parameters in your string here. You do an exec or something like that. But it works very similarly, accepting the parameters, the values from the parameters, and not passing them as a part of the actual string, the actual query string that's executed. So there's no way for us to come here now and say x or x equals x, inject that string into our into our query, so it's actually becoming part of our actual query. Not good. All the users are returned. Let's try the same thing with our parameterized query. No records were found, and here you can see that these values are not part of our query string because they're stored in these variables, so and getting processed in the database engine. So that is how SQL injection is blocked by parameterizing your queries. Very important stuff. Like I said before, though, there are a number of other methods for doing SQL injections, and of course it's also database dependent. MySQL also has some vulnerabilities, but it also has some of its own injection handling. Trying to think if there's anything else. Try Ambrosia 21. I love code. Go ahead and log her in. You can see my connection string with the login. Successfully return one value and returns the user profile. Should work. No row at position 0. So I must have messed up her login there somehow. No, because it shouldn't have passed it there. I wonder if my collation is off. Password pass, collate Latin. It should have been accepted. Now I'm kind of curious here. Let's see where I messed up. I'm going to throw in a message box here in my parameters to test this here real quick. Message box peed up parameter name, and break that out, and p dot value. I want to see what parameters are actually being passed through here. See if I made a mistake or something. Ambrosia 21. I love code. What's your name? Ambrosia 21. Password Ambrosia 21. Okay. Alright. Time to debug my code. That's a ridiculous mistake. You guys probably caught it before I did. Yeah, right here. See, I accidentally used txtuser. I'm passing my password as txtuser. Now it's supposed to be txtpass. Oops. Silly me. Sorry about that. That's programming for you. It gets kind of mind-numbing after a while. And we'll see if our login form accepts it. Ambrosia21. Password is I love code, capital C. Pass I love code. And we have a success. Okay, so no more SQL injections there, and we successfully return the username. Let's try entering the password in lowercase. I love code. Ambrosia21. Pass variable is I love code, and it didn't like it because we forced case sensitivity on it with the collation. Pretty cool stuff. So that is how you parameterize your queries and hopefully prevent SQL injection attacks against your database. Now, one thing to keep in mind is that, you know, passing these in, if there is some bad code in there, especially if you're running a website or something, you got to be cautious because if your users are, you know, taking this from a web login standpoint, and the user has the ability to input values into the database or use an if they inject an insert or something like that, if they can't get through the one way, what they can do is get around the back door by injecting, you know, JavaScript or something else into your table, you know, knowing that it might not crash. It's not going to kick them out with the SQL injection on the one side, or if they can't access it, or if they can't run something from the user side, maybe they can run it from the server side. So you know, they might, you know, embed some nasty HTML or JavaScript in their database entry, and the database accepts it, you know. So that's where form validation comes in, removing certain keywords and things like that. These are, you know, it's another tier of protection against SQL injection. So it's definitely a worthwhile topic to look up for any database programmer out there. You should definitely know about SQL injection, so do your research there. It's worth the look. Anyway, I hope this tutorial has been helpful for you. Sorry it kind of dragged out there for a while, but we got through it. If you liked it or if it was helpful for you, you know, give me a thumbs up and share it with your friends if you know anybody that would also find this useful. I appreciate that, and I wish you all luck on your projects. Take care and catch you soon. Bye-bye.